right, so in this lesson we are going to identify and interpret attributes of linear functions given an equation and the situation. So example 1, or the only example really. Jennifer and Vanessa are taking down the flag after school for JCC. The function a of p equals 32 minus 4 over 3p describes the relationship between the number of times they pull the rope and the altitude of the flag. So as usual, the first thing we'll do is we'll try to figure out what the independent and dependent variables are. So let's figure out what things can change. So from our equation, we know that we have a p and an a of p. So describes the relationship between the number of pulls, the number of times they pull the rope, and the altitude of the flag. So the altitude will be affected by the number of times they pull the rope. So the altitude is the dependent variable. So the altitude. So instead of just writing a, we are going to write a of p because altitude is a function of the number of pulls. So the altitude of the flag. And that will be dependent on the number of pulls. So P for number of pulls. Now the equation that they gave us was A of P equals 32 minus 4 over 3p. Don't forget we can write this a bunch of different ways. A of p equals 32 minus 1.33, repeating p. We can also write it as A of p equals negative 4 over 3 p plus 32. And we have A of p equals negative 1.33 repeating p plus 32. So the y-intercept. We know that the y-intercept is this 32 right here, this constant. So more specifically, it's 0, 32. Now what does that exactly mean? This means that the initial altitude of the flag was 32 feet. And we'll put in parentheses before any pulls. Okay, so our constant rate of change, we know that this is the fraction, or the decimal that is attached to this variable, to the independent variable. So it's the coefficient with the independent variable. So we will say that's the change in altitude according to the change in pulls, which is negative 4 over 3, which is negative 1.33 repeating. We know that this slope is talking about how the altitude changes as a result of the pulls. So the altitude of the flag, I put an E on flag for some reason. The altitude of the flag decreases by 4 feet every 3 pulls. And we can check that too. The altitude is 4 feet for every 3 pulls. That actually decreases by 4 feet every 3 pulls. Now let's make a table with this. So let's do the pulls and the altitude as a function of pulls. So our initial altitude was 32 feet, and the change in altitude according to the change in pulls. So the altitude decreases by 4 feet every 3 pulls. So 3 pulls would be 3 pulls, and then 6 pulls, and then 9 pulls, and then 12 pulls. The altitude would be 32 initially, and it decreases by 4, so we end up with 28. And then we get 24, 20, 16, so on and so forth. So let's look at this graph. So our graph 0, we'll start here, and we have to start at 32. So we're not going to get to 32 here, but we can count well, first we'll do this. Let's label our axes. This is our altitude. It's a function of pulls. This is our pulls. Let's talk about pulls first. The pulls are going by 3. We don't have to go by 3. We can go by like 1 or 2. We usually go by 1, right? But I'm going to go by 3 just to show you something. So 3, 6, 9, 12, 15, and so on and so forth. And the pulls, the altitude has to be all the way up at 32, but then it's going to decrease by 4. So since that's going to happen, I'm just going to count by 4. So 4, 8, 12, 16, 20, 24, 28, 32. So I'm going to start at 0, 32. I'm going to go down 4. Remember, we're kind of at 4 every 3. 4 every 3. 4 every 3. 4 every 3. 3, and we keep going. So that's going to be, so that's 15, 18, 21, 24. Cool. And that's our graph. Oh, we should probably fill in our line. Oh, that's the best I can do right then. Okay, well, actually, we'll see. Maybe, this might be worse. I'm not sure that's really better, but we'll keep it. So our x-intercept. We know that the y-intercept is right here because this is like our y-axis. Well, this is our x-axis. So our x-intercept will be where it intercepts the x-axis. So instead of being 0, something, it'll be something, 0. Something, 0. Right here, we can see that is actually 24, 0. So what I actually gave you this space to do is find the x-intercept. I know we can see it here, and we can even see it here. So it says 24, 0. So I'm going to keep counting. So that gives me 18, 21, 24. So it decreases by 4. So this is 12, 8, 4. Oh, something's wrong down here. So 3, 6, 9, 12, 15, 18, 21, 24, 4, 8, 12, 16, 20, 24, 28, 32. Down. Let's see. Minus 4, 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 4, 3, 6, 9, 12. Oh, there should be a 15 here. That's what I did wrong. So this would be 15, 18, 21, 24. So this is 16. This will be 12, 8, 4, 0. So what I want you to do first is I want you to star or circle the x-intercept here. But I also want you to box the x-intercept here. And then let's prove that this is the x-intercept. So let's prove that this is the x-intercept. How do we get the x-intercept if we didn't know it? Well, I'm going to write one of my equations. A of p equals 32 minus 4 over 3p. Now remember, my x-intercept will be when the flag hits the, well, shouldn't hit the ground, but if it hits the ground. So when the y is 0, when the dependent variable is 0. So I'm going to change this. This goes right here. Right here. We're going to make this A of p 0. 32 minus 4 over 3p. So I'm going to subtract this 32. I'm going to subtract this 32. I get negative 32 equals negative 4 over 3p. And then I'm going to multiply everything by 3. Well, I'll show it like this. I'm going to multiply both sides of the equal sign by 3. So I get negative 96 equals 4 times 3 is 12. 12 divided by 3 is 4. So negative 4p. Then I'm going to divide by negative 4. And I end up with p equals, a negative divided by negative is a positive. 96 divided by 4. So 96 divided by 4. 4 goes in here 2 times. 4 goes in 16 4 times. So 24. And that is actually what we got. So this should match this, and which should match this right here. And that is it. Thank you.